Welcome to Sift Tutorials. In our tutorial series on Sift Explore, we created a reference power curve and generated an expected power signal. Watch our tutorial on creating reference power curves for detail on what the analysis does. In this tutorial, we will be adapting this analysis to be managed and deployed across multiple sites at once. We navigate to analysis definitions within the Manage Portfolio section and create a new analysis. Then we can name it and set it to be a bins map. Click the pencil to configure it. To create a power curve, select power for the y-axis and wind speed for the x-axis. Note that we aliased the signal names in our previous tutorial, so we can use this exact bin map for all sites in the portfolio. For the x-axis bin settings, we could set fixed values, or we could use a variable to adjust power curves to normal wind speed ranges for each site. We want to cover the wind speed range from 0 up to turbine shutdown due to high wind, so we need to create a variable for the maximum wind speed where the turbine is expected to operate. We name this wind speed max during operation. This was 25 on our example site. Let's save and go back to our bins map. Now, we can toggle the maximum bin field to be a variable using this button, and we set it to be the variable we just created. As we are wanting to create 1 meter per second bins, we can also set the number of bins using this variable. Note that we add 1 to our maximum wind speed to also include 0 in our map. These settings make it so that any wind speeds above 25 meters per second are not modeled. Since the purpose of this analysis is to generate expected power in partial and full load, we do not need to be concerned with wind speeds above the maximum bin. Next, we're going to focus on setting a reference period. This needs to be site-specific, as it is affected by the age of the site and things like recalibration of anemometry. To do this, we'll create a flag to capture the reference period. We make a new flag called reference period, set it to neutral, and add it to our site. Then, we can set the rule to only be defined from its start and end date. For this site, let's select the year 2020. This can then be adjusted for each site. Let's save and go back to our bins map. We use the filter string to select only neutral data and filter further using the flag we just created. We add a grouping by instances to create a power curve for each turbine, rather than one for the whole site. Gap filling configurations can be specified here. We will only use a forward fill on this bin map to deal with low data coverage at rated power. Data coverage in partial load is expected to be good as we are using a year's worth of data. If it is not, we should tune the reference period to have better coverage of the partial load region. We aim to use this bin map to create an expected power signal using observed wind speeds. This can be set up in the data signal synthesizer. We select our interpolation method to be piecewise cubic Hermite and the source data to be the median so that we are less sensitive to outliers. Let's tick the Calculate Residuals box to also get the difference between expected and actual power. Then we can save this analysis. It gets highlighted in blue on the definitions page to show which analyses have been edited. To confirm the changes and apply the model, click Save and Run. Once it has successfully run, this will be indicated by a green tick. Now we can go back to our Signals section to set up aliases for our synthesized signals. We make one for expected power and one for residual power. Let's have a quick look at the analysis output. We'll devote a tutorial to analysis visualizations soon, but for now, I'll just quickly set it up. From this, we see all turbines are in general agreement, there are no unexpected deviations, and all the curves are populated up to 25 meters per second. Our reference period and flagging therefore seem appropriate for this site. In this tutorial, we set up a managed analysis for a reference power curve. We defined a variable to represent site-specific wind speed shutdowns and a flag so each site can have its own reference period. Then, the Sift monitor bin map settings can be the same across all sites using these standardization options. In our next video, we will use the synthesized signals to set up a KPI to track power curve efficiency.